If I create a language that compiles to Java bytecode, then I get the garbage collector, object serialization, RMI, class loaders, threads, a concurrency mechanism. I get all of that stuff for free. I don't have to worry about any of those details. I can focus on what I want to focus on, which is to say, the language. The interesting and new ideas that I have for you to be able to get more stuff done. Hello. There we go. How many of you would consider writing Java code without an IDE? How many of you would? You don't get any real work done on a daily basis, do you? You know, I just want to see if you'll see me down here. I'm sitting in the very front row. I'm going to stick my hand up and see if you can see me when I stick my hand up for an obviously don't raise your hand kind of question. Now he's trying to hide behind his buddy. I'm sorry, don't hurt me. Crazy American, don't invade my country. Seriously, right? We have a huge wealth of tools in the Java space. The IDE is just sort of the tip of that iceberg for building things, right? We have IDEs that will finish your method calls for you and make sure that it will compile as you go. We have IDEs that will generate code, that let you customize the code that will be generated, right? We have all of these tools, these static code analyzers, to see if you have any concurrency bugs. How many people have played with find bugs before? Find bugs is an amazing piece of software just because it can literally look at the way your code is written and predict whether or not there will be a concurrency bug, amongst other things. You drop this in as part of your Ant build, boom, you're done. And it's literally finding bugs for you that you will otherwise have to debug by hand. And even when you get to the point of trying to debug by hand, I mean, there's some really sophisticated debuggers out there, right? There's the JSWAT debugger, which is now baked into NetBeans. Your IDE has its own debugger, et cetera, et cetera, et cetera. We got these profiler tools to help you figure out where the slow spots in your program are, right? Where's the slowest part of your program? The user. Right? I want a profiler that says, yes, the worst part of the program is the idiot sitting behind the keyboard. That's the profiler I want. See, boss, I told you. It's a user problem. It has nothing to do with my code. We have all of these tools, and for years, we didn't. I mean, how many people remember back in the early days of Java, right? The Java debugger was what? System.out.println. Fortunately, we are more advanced than that now, right? Now we have log4j. So now we can do system.out.println to a file. That makes code robust. The language designers for years have had some very, very primitive tools to work with. If they wanted to build a parser, they had two choices. They could either work with Lex and Yak. Anybody familiar with these tools from your days at university? Yeah, there's a reason why it was called yak. Do you know what we in the States, right? That's a verb. To yak is what happens after you drink too much, right? It was supposed to stand for yet another compiler. Instead, it turned into yet another obscure language that I will never use in my programming career. But that acronym didn't come out so well. And it turns out that these are genuinely useful tools. They're just difficult to use, and they're kind of painful, and they were geared towards writing C-based, languages and parsers and whatnot. And we, of course, were in the Java space, so we didn't really spend a lot of time there. The tools have gotten so much better since. We now have tools like Antler, which is another parser generator, but it generates Java code or C# code or C++ code, and it's very object-oriented. You'll use the visitor pattern to walk through the tree structure that Antler will create when it parses your code. The grammar files are actually pretty easy to understand, and that's just one tool available. There's also another parser called the Gold parser, similar kind of idea, parser generator, I should say. Even if you don't like the idea of code generation, over in the functional side of the world, functional languages are creating this concept known as parser combinators, where you can write something that looks like BNF grammar, right? Remember that from university where you specify the term equals and then what makes up that term, and it's a really convenient way, very succinct way of representing what a language grammar will look like. We actually have grammar debuggers. If you're working with Antler, there is actually a tool that can plug into either Eclipse or IDEA. I don't think they have a NetBeans plugin yet, probably because the only people who use NetBeans are people who work for Sun Microsystems. And it will actually help you debug your grammar to make sure there's not some weird edge case where something you didn't intend will actually be allowed through. Normally, the language designer has to write all that test code himself and try it out and play it out and see if it works and build some unit tests, etc. Right? Debugging without a debugger sucks. All of these tools are now available to language designers to make it easier for them to build languages. There are not only front-end tools for handling the parsing, but also back-end tools for doing the code generation or creating interpreters. Over on the Microsoft side of the world, I know Java guys don't like to hear about Microsoft, but they're doing some interesting things, and we should pay attention. Over on the Microsoft side of the world, Microsoft is creating what's known as the DLR. The CLR is their equivalent to the JVM. The DLR, the Dynamic Language Runtime, takes all of the common execution, the interpretation side of building a dynamic language, and is creating it into a common library so that now if you just parse into DLR trees, the DLR can take care of it from there and execute your code. You don't have to build the interpreter yourself. If you want to actually generate bytecode, well, there are libraries, JavaSys, ASM, BCEL, to make it easier for you to generate those libraries. It turns out that these tools make it phenomenally easy for you to build these languages so that now we can start making the higher decision making, which is to say we can start thinking about different language ideas. See, for a long time in the Java space, we had this idea that objects were it. We're done. Anybody else who's been thinking about languages can just go home now. There's nothing left to say. This is how God thinks about the world, is in terms of objects, right? When God creates something, he says, person P equals new person, parens, right? And we don't quite know what the constructor looks like. If we did, we could do it ourselves, right? As it stands now, we have to go to a factory-based approach. He doesn't have to, right? He could kick that whole process off by hand. Wow, you guys just did not laugh at that factory joke. Jeez, I got to work on my material. Point is, now we can start thinking about new ideas, new concepts, new approaches. Why are we interested in doing this now? Because again, from 1995 through about 2000, right, objects, I mean, if you weren't doing something object-oriented, clearly you had no clue what you were doing. If you walked up to your boss and said, you know what, I really don't think that this program that I'm about to build, I really don't think it fits an object paradigm, your boss would fire you. Because if you weren't doing objects, clearly you were not the senior Java developer that you pretended to be when you interviewed, and so therefore we got to get rid of you just as quickly as we can, before you infect the other developers with your particular brand of madness. And so what happened when we started working with systems that said, all right, part of what we need to do is we need to take some money from here, and we need to put it into this account, and we need to take some money from here and put it into this account, and we need to make sure that this particular note is handled, and we need to make sure that all of this is done under a transaction, so either it all succeeds or it all fails. The Java developers of the world got together and said, how do we do that in objects? I know. We'll create this container object that will take your little objects, which, by the way, cannot inherit from anything and cannot implement the particular business interface, but the interface must still be there, and we're going to have to require you to implement an interface but not any of those methods, because that will actually come from something else. How many people remember programming in EJB? Did it make any sense at all? Right? Of course not. It made no sense whatsoever because we were thinking about it from an object-oriented perspective. EJB was not object-oriented. That's the secret shame of EJB. It was never object-oriented. The people who worked on EJB, they knew that. They were trying to build a transaction processing system. Transaction processing systems are intrinsically not object-oriented. They're transaction-oriented. They didn't get why everybody was so upset. This is what you wanted. You want to be able to scale madly, right? TP systems had been able to scale madly for years, for decades.